Hi guys, so I'm going to do the Unit 2 study guide in sections instead of making it one full video with chapters in it. I'll just make 4 videos talking about each of the lessons. So this is over 2.1 and we talked about whether or not a graph was a function or not. And then if it was a function, stating the domain and range in set builder notation, and then if it's not a function, justifying why it's not a function. Now on the test, you have to give me this justification, okay? Whether it's by an algebraic proof, you cannot just put it does not pass the vertical line test. That is not a justified reason why. It doesn't not tell me anything about the function itself, okay? So number 1, we definitely know this is not a function. And let's say we take a point, for example, where x equals 1. We have 2 points. That's the output. So we can either say that this function is not well defined, as in what was on the slides, okay? Or you can actually give me the proof, which is f of 1. One of the outputs is going to be somewhere around, I would say, 0.5. That one looks like the output is going to be around 0.5. That one looks like it's going to be around 2.5. And then if you tell me that the outputs do not equal each other, okay, so we have to have a well-defined output for an input, okay, and this doesn't. It's ambiguous. Okay, so therefore, this is not a function. Number 2, let's see. There are places where it looks like the input actually overlaps. If you look right here and right here, but then right here, they're open circles. So it's actually a function. This is a function. And the way that you would put that into set builder notation, the domain of the function is x such that x is an element of all real numbers. And once again, we decided, hey, if at this point, we kind of assume that all of the x is going to be real numbers. Since it's on the x and y coordinate. And then we figure out what x's could be. Okay, we start at -4 and we travel this way. This x equals -1 is included here. All of that is included, and it stops at 5, so that we can put as a compound inequality. Okay, something that looks like that. You can write it as the intersection also x such that x is an element of all real numbers, and then you can put x has to be less than or greater than, or less than or equal to 5, and then it would be the intersection of x is greater than or equal to -4. Okay, let's take a look at the range. The range of the function is going to be y such that y is an element of all real numbers. And once again, we can go ahead and identify that. And you can write it in set builder notation and just say x equals, what is x equal? X equals -2 and +2. So x equals 2, or x equals -1. Or you can put it into simple sets. So the range of the function is -1 and 2. Okay, it doesn't matter. It means the same thing. Okay, good job, guys. Okay, number 3. This is definitely a function. It has what looks like an inflection point. Okay, but we're not identifying inflection points. Okay, this is definitely a function. Okay, and the domain of the function is x such that x is an element of all real numbers. The range of the function is y such that y is an element of all real numbers. And then let's go ahead and identify y. It looks like this is a horizontal line right here. It looks like these are horizontal lines. Okay, so we can identify it as all the numbers between -1 and 1. Okay, good job, guys. Okay, next. This is definitely not a function. Not a function. And there's two reasons why. It's not well defined. It's ambiguous. The output of x is going to be ambiguous. So if I put in f of 5, and f of 5 is going to give me 4, and f of 5 is also going to give me 5, and f of 5 is going to give me 7, and 4 does not equal 5, does not equal 7. So that's why it's not, therefore it's not a function. And also, no, that's number 1. Number 2, okay, does not act on, the function does not act on all elements of the domain. So by the way that the arrows are pointed, we know that this is going to be the domain, and this is going to be the range, and that's codomain, right? And we know that the range is going to be mapped from the domain, the way that the arrows look. If you look right here, this 3, they have defined as a domain, okay? And 4, they have defined as the domain. It does not get mapped to anything. So x equals 3 and x equals 4 are not mapped. Okay? So while, yes, telling me that it's not a function is good, but you have to explain to me why it's not a function. You don't have to use the terms like well-defined or does not act on all elements of the domain, but you have to be able to know that in IB, that's number 2 right here. When domain is listed and it doesn't get used, does not have an output, then it's not a function. Okay? Good job. Okay, so let's take a look. We know that this is not a function because of that right there. Not a function. Once again, if you tell me that it does not pass the vertical line test, and so what? Vertical line test is a man-made test. It has nothing to do with math. Okay, it doesn't pass the vertical line test. What does the vertical line test mean? Okay, if I just say, hey, it doesn't pass the Ahlstrom test, well, I just made that up. Okay, so once again, this is a not well defined. That means the outputs are ambiguous and it has the same inputs. So once again, to prove it, f of 1 equals 0, f of 1 equals 1, 0 does not equal 1, so therefore not a function. Okay, that is an algebraic proof of whether or not this is not a function. Okay, and therefore it creates a vertical line, or it fails a vertical line test. Okay, now let's take a look at this. Okay, so every time I put in a -1, it gives me pi. Every time I put in 0, it gives me a pi. Every time I put in 3, it gives me pi. Every time I put in pi, it gives me pi. Guys, this is a function. It's well defined. And I mean, it's written in coordinate form, so it has to have all of the domains used. Now, if I said -1 and it gives me like an empty set, which I won't, okay, which I won't because you guys are not familiar with that, okay. That's another like notation that you have to be aware of. But so domain of the function. Now it says set builder notation, but I really don't want to write this in set builder notation. So the other option is to just write it in simple sets. There you go. Okay. Or I could have it where I define the function at the very beginning and say, hey, given that the domain of the function is something like -2, -1, 0, 3, and pi, and the range of the function is pi, you take a look. If I was given those domain and ranges and -2, and this was included along with it in the way that they form the relationship, -2 does not get used. If I was given that, then this would not be a function. This entire problem would not be a function. Okay, anyways, let's go ahead and erase that. I don't want that to be my key. Okay, let's see. Okay, so I'm going to stop the video on to 2.2. Good job, guys.